Welcome to my physics class for today. Today we want to look at a topic called equations of linear motion. Equations of linear motion. So we have four equations derived or propounded by Sir Isaac Newton. Isaac Newton is one of the greatest scientists, and he observed the motion of a body along a straight line, and he developed four different types of equations which we can easily use to tackle or solve any motion pertaining to linear, and that is why we call it a linear motion. And these four equations are: number one, V equal to U plus AT, and second one, let's call this equation 1. Second one is V square equal to U square plus 2AX. Let's call this equation 2. Number 3, X is equal to V plus U all over 2, everything times T. Let's call this equation 3. And the number 4 is X equal to UT plus half AT square. Let's call this equation 4. These are the four equations derived or propounded by Sir Isaac Newton for solving any linear motion. Here, we want to look at how these four equations, how they can be proved. How can we prove that this is equal to this, or V square is equal to U square plus 2AX, X is equal to V plus U all over 2 times T, and how can we prove that X is equal to UT plus half AT square? Here, we need to understand the parameters or the terms in these equations. Our U here, this U is called initial velocity. U is called initial velocity, and our V is called final velocity. These two are measured in meter per second. That is the standard unit of velocity. Initial velocity is the speed which that motion used to start the motion, or that object rather used to start the motion, while V is the speed that the object used to stop that motion. So we also have X. X is the distance covered by the object, and distance is measured in meter. That is the standard unit. And also we have T. T is equal to time. The time the body or the object used to perform that motion is what referred to as time. And also we have A. A is acceleration of the body, and is measured in meter per second square. So these are the parameters or the terms in these four equations of Newton's motion. Don't forget, our acceleration determines the direction of any motion. That is why in some equation they do write plus or minus here, plus or minus, plus or minus. That is, the direction of the motion determines whether we are going to have positive or negative value here. But how are these four equations? How can we prove them? Proved. This method I want to use is for elementary stage. We also have advanced method which we can use to prove, but this proving is majorly made for the secondary school student. So let's prove these equations. If you recall that acceleration is equal to change in velocity over time. And when we say change in velocity, that is different in the velocity. Like I said, we have two types of velocities. That is, we have initial velocity and final velocity. So the change, the velocity a body used to start a motion, and the velocity the body used to stop the motion. Then their change, now their difference, is what we refer to as change in velocity. So we are going to say acceleration is equal to v minus u. That is what we mean by change in velocity. All over what? Time. Now, if our a is equal to change in velocity over time, by the time we cross multiply here, we are going to have a this times this, that is v is equal to v minus u equal to at. And if you make v the subject of formula in this equation, we are going to have v is equal to u plus at. This is equation 1 proved. We discovered that this is the same thing as this. So that is how this equation is derived. And secondly, we want to prove any of this. So this has gone. Also, we notice that change in velocity, that is, or we can say average velocity, is known as v plus u all over 2. When we say average, we all understood in mathematics that average has to do with mean. Let's say you have two terms, you are considering 2 and 4. If you want to find average of 2 and 4, so the average, which is the same thing as mean, will be 2 plus 4 divided by 2. And this will be equal to what? 3. So that is what you mean by average. Average has to do with the center value or the mean of that value given to you. Therefore, we have two velocities. Since we have two velocities, the initial and the final, the average of the velocities will be v plus u all over 2. If this is average velocity, and we know that average velocity is also total distance traveled over time taken. So average velocity is equal to total time over total distance over time taken, or the displacement over time. We can say velocity or average velocity is equal to displacement all over time. That is total distance traveled over total time taken is our average velocity. We can now equate these two equations. Since average velocity is this, and average velocity is also total distance taken over total time. It means this is equal to this. That is, we can say V plus U over 2 is equal to X over T. By the time we make X subject to formula from this relation, if you make X subject to formula in this relation, we are going to have, if you cross multiply this times this, we are going to have X or 2X, X times 2, or simply we can just say X is equal to this times this direct. We can just say X is equal to V plus U all over 2 times T, and this is for equation 3. So equation 3 is proved. This is how this equation 3 is derived. Another thing that we want to look at now is this and this. So to get this or this, all we just need to do is to substitute this equation 3 into equation 1 by making any of the parameters subject to formula. What I'm saying is we can make V here subject to formula and we substitute it to this equation, or we make T or U the subject of formula, we insert it to this equation. We are going to get any of these two equations. So let me substitute equation 1 into equation 3 directly. Let's see what we are going to have. Substitute equation 1 into equation 3 for V. Then we are going to have X equal to our V from equation 1 is this. By the time we substitute everything here for V, we are going to have U plus AT, then plus our U all over 2 times T. So let's simplify this and see what we are going to have. And if we simplify, we are going to have X is equal to this plus this will give you 2U plus AT. Don't forget all over 2 times T here. And this is the same thing as 2U. And if you use this to multiply this, 2UT plus this times this will give you AT squared all over 2. And this can also be written mathematically as 2UT all over 2 plus AT squared all over 2. And you believe that this will take care of this, and our X will be equal to UT plus this can also be written as 1 over 2 or half of AT squared. So this is what you call, or what we derive in equation 4 here. So this is equation 4 proved. Now left with equation 2. To get this equation 2, we discover that T is not in this equation. And what we are going to do, out of these 3 equations, we can make T subject to formula and substitute for other T in other equation. What I'm saying is, since in this equation 1, T is here, we can go to any of these equations that have t again and substitute for t here. But let me make t subject of formula from equation 1. Then I will now substitute it to this equation here. Let me see what I will get if that is done. From equation 1, make t subject of a formula and insert into equation 4. So let's do that. From equation 1, we have v is equal to u plus at. This is equation 1. And by the time we make t subject of formula, this comes here, we have v minus u equal to at. So divide both sides by a. We have t equal to v minus u all over a. Let's call this equation asterisk. Now we are going to substitute this into this equation 4. That is, anywhere we see t, we can substitute. Or we can also use this by substituting for t here in equation, in this equation we just derived, which is here equation 3 here. But since in our statement we said and substitute into equation 4, therefore we are going to use equation 4, but we will arrive at the same answer. Now we want to insert this into equation 4, like I said. So we have from equation 4, x is equal to ut plus half at squared. And we have x is equal to u times t. And what is our t? This is my t. V minus u all over a. That is v minus u over a. Then plus half a into t. And what is my t? V minus u all over a all squared. Then I will simplify this. So this time this will give me vu minus this time this will give you u squared all over a plus 1 over 2 times a into, by the time we expand this twice, this means v minus u into v minus u all over a squared. That is a squared, then this squared, this time this twice. So here I'm going to have a v u minus u squared over a plus, this can be written as a over 2 into, let me expand this bracket, v times v will give you v squared, and v times this will give you minus v u, and this time this will give you minus v u, this time this will give you plus u squared all over a squared. Okay, and this is the same thing as a v u minus u squared over a plus, I can cancel one a here from this place so that we have v squared minus this, and this will give you twice vu, then plus u squared all over a, left with one a here. And don't forget we have 2 here, so 2a, 2 times the remaining a here. Now this is x. I want to find the LCM. Let me find the LCM here. I will get x equal to, the LCM is 2a, so 1 goes into a is a, and a times everything here, I will get a v u minus a u square plus this goes in this 1 times everything here give me v square minus 2 v u, then plus v u square. So what are the like terms here that we can cancel easily? So let's look at what is here. You discover that this is this and this. Don't forget there is 2 here, I'm sorry. This goes in this will give me 2 to be 2. So a goes in 2a will give you 2. So this should be 2 and this is 2. So this and this, they are like terms. 2 vu and minus will take care of each other. This will cancel and I will have this and this. When you cross multiply this time this, you have 2ax equal to v square. So minus 2u square plus 1u square will give you minus u square. Let's take this to this side so that we can standardize it to this form. I want to make v square subject to formula. That means this will come here, and when we do that, we are going to have 2ax plus u square is equal to v square. Therefore, we can say our v square is equal to 2 of u square plus 2ax. And this is equation 2. Equation 2 proved. So these are the 4 Newton's equations of motion. Don't forget, I said this method I use is for elementary level. If you are in secondary school and you want to learn how these formulas are proved, you can easily apply this method. But for advanced method, we also have ways which you can do that by applying your calculus level. So this is what you have for today. In our next class, we'll take questions and use these equations of Newton's motion to tackle some questions. Subscribe, like, and share. Thanks so much. I love you all.